Welcome and hello. This is a video exercise using the HEC RAS controller titled Parsing Input File Data. This topic is similar and a little bit more complex than what was covered in lesson 14, where the topic was introduced. What we're going to do is build out a very simple HEC RAS 1D model and then use the HEC RAS controller to parse out some of the data that we're going to be looking at this time in the steady flow file. All right, so without further ado, let's get going. I'm first going to open my HEC RAS. I've got a project started already. If you don't already have the geometric data window open, go ahead and open that up. I have it down here below my main file GUI. I'm going to sketch out a river reach here and then double click. I'm going to call this river A and then reach 1. All right, so that's done. I'm also going to sketch out a second river. So I'm going to click on river reach, put it right over here, and I'll call this, double click first. There we go. Let's call this river B reach 1. All right, so I've got a river A, a river B. Yes, sure. And now I need to add some cross sections. So open up the cross section data editor. Let's start with river A first. Let's first add a cross section. Let's put this at the bottom of the reach, river station 0. Okay, let's add some cross section data. Boom, there's that. So let's just fill in some of this other metadata over here. And then we'll just say the overbank is from 40 to 100, and then apply data. There's the cross section. I'm going to add another cross section at the top of the reach here. So let's say this is a 500-foot long reach. I'll go options, copy the current cross section to the same river and same reach. I'll go ahead and use river station 500. And actually, while I'm here, I'm also going to copy that same cross section to the downstream of this river B. So options, copy the current cross section. We're going to go river B, and that's going to be at river station 0. Okay, actually also a third copy to the top of river B, reach 1. But that's a shorter river. We'll say that's a length of 300 feet. So river station 300. Okay, we got a few things to do here. Let's go ahead and define the cross section at the upstream end of river B right up here. So that's a distance of 300. And then let's just go ahead and say it's a 0.1% slope so that the elevation increase is would be 0.3 feet. So I'll go options and then adjust elevation. Here I'll say 0.3 and OK and apply. All right, we still need to make edits to the upstream cross section of river A now, which is this one right here. The distance to the next downstream cross section is 500 feet. We use the same slope of 0.1%, so I will adjust the elevation and then add 0.5 and OK, apply and close. All right, so we have our two rivers. We have our cross sections at the very upstream and downstream end. Just to make it look a little bit more normal looking, I'm going to add intermediate cross sections by interpolating. Go up to Tools, Cross Section within a reach. There's nothing wrong with 500 feet or 300 feet between cross sections, but I'm going to make it 100 feet. This is for river A. And then again for river B, interpolate and close. All right, so this is all we need to do for the geometry. Like I mentioned at the beginning, we're going to be using the HEC RAS controller to look at and parse specific data within the flow file, the steady flow file. So the geometry itself isn't as important as it would be if we were using it with the HEC RAS controller. I'm going to go File and then Save Geometry. Just call this Base and then OK. All right. Now it's time to make some edits or create a steady flow file. So edit steady flow data. Here is the river A and river B data. I'm going to make 3 flow profiles. The default is to have a flow at the upstream end, the upstream most cross section of both reach, which is river A 500. That's this first line. Then river B at cross section 300, river station 300. We can also add additional cross section data. So let's just go ahead and fill this information out. I'm going to say that the PF1 is 100 CFS, PF2 is 200 CFS, 200 CFS, profile 3 on river A is 300 CFS. All right, now down here to river B, I'll make up some different numbers just to kind of get some variation. We'll say PF1 is 120 CFS and profile 2 would be 150 CFS, for instance. I'm going to leave profile 3 blank. For instance, we're just not using it for whatever reason. But I'm also going to add an additional flow data at about River A and the cross section at River Station 200. So River A, routes 1, and let's select 200. Click on Add a Flow Change Location. Now for PF1, I'll just increase the flow a little bit. So I'll say like 110, and then over here 250, 400, right? That may represent some additional incoming flow, lateral flow, like from a tributary that just doesn't have to happen to be drawn in on this plot. All right, I'm going to go ahead and save this. So we'll say File, and Save Flow Data. Call it Base as a title. The file itself has been saved. We'll go ahead and close that. You can see up here in the file GUI, we have our base geometry file and our steady flow file. Over here in the left column is the title, but over here in the right is the actual path to the file. .g01 for the geometry and .f01 for that steady flow file. Here is the project directory so far for this project. We have our .prj file, and then as we saw in the file GUI, project.g01 for geometry and project.f01. This is going to be for the flow data, the steady flow file, which I'm actually going to copy the path to right now. So right click, copy as path, and let me move that out of the way. I'm going to bring up Microsoft Excel and then just go ahead and paste that path into this cell C2. A few things I want to do here is go File, Options. I want to use the R1C1 reference style. So Formulas and then R1C1 reference. Okay. So this is the path right here to the steady flow file. I'm going to open up my ribbon and then just call this steady flow file path. All right, and then let's just make this a little bit wider. Cool. So there's that. This is the cell that we're going to reference when we want to open up this file for reading the input data. Down below here, I want to use the HEC RAS controller to gather some of the flow data from this steady flow file and then print it out down here. So what I want to do is go river, reach, river station, and then I want to have the flow profiles printed out right here, PF1, PF2, and PF3. And then I actually want it to say river A, reach 1, and then just like the table we were looking at over in HEC RAS, let's see, this table right here, I want it to print out PF1, PF2, PF3, and I want it to show the rivers, the reaches, basically recreate this table right here, but inside of Microsoft Excel. Why you may want to do that, a number of reasons, but this is simple enough. It's really just, like I said, an exercise to kind of get used to finding the data and then parsing out the data based on its particular format within the text file that is the input file used to run this model and to load the model. So let's go ahead and head over to Excel again. So here is our Excel. In fact, let's go ahead and open up steady flow file and then just take a look at what we're dealing with here. So right click and open that up. I'll open it up in a text editor. Here is that file on the screen. Looks pretty straightforward and easy to read and understand. The flow profiles are listed on this line 4 right here called profile names enter. So we have PF1, oops, don't do that, PF2 and PF3. So those are comma separated values, meaning the length of the profile name, which we can change in the user interface, but the length is not determined. It's not like a fixed length of 8 characters or 16 characters, anything like that. This is using the comma delimited parsing. And then after that, we have our 3 different river reaches that are associated with the steady flow data, all starting with this string river space reach ampersand RM equals. After that, we have comma separated values for the river name, the reach name, and the cross section. It says RM. I'm not sure if that's supposed to be river mile, but RS is kind of what I've been using as a term for river station. And then the next line down, notice this is the flow rates, the actual numbers that we typed in for 100 CFS for PF1, 200 CFS for PF2, and then a flow of 300 CFS for PF3. So that same pattern repeats all three times for all 3 of these entries in the steady flow flow file. Notice this last one right here is for river B. The first 2 were for river A. So that is consistent with what we had in the steady flow file right here, river A, river B, reach, river station number, and then flow profile and those numbers. So what I do is I propose we write a script to read in this flow file, the project.f01 file, and then use some string operations to parse this file and extract the data we want here to put into our Excel worksheet. All right, so I'm going to minimize that for now. Let's go up to the developer tab. If you don't have the developer tab, you have to add that in by going up to File, Options, then Customize Ribbon, Developer tab. Check that on. OK. And then once you are on the developer tab, click this left button for Visual Basic. All right, so here's the Visual Basic window. I'm going to add a module first. So insert, add module. I'll just write all my code right in here. And then also I need to make sure that my reference is added for HEC RAS. It looks like it's not right now. Okay, let's do that then. So just scroll down to H. If you have HEC RAS installed on your machine, then it should be one of these options. I happen to have it installed a number of times here. I'm looking for the version number. Where'd it go? Okay, there it is. 6.6 is the version I want to be using here. And okay, so use whatever version you want. And boom, now we're ready to insert our code. And there is all the code right here. It's a little bit lengthy, but we'll go through it together and pick out a few of the specific details of interest. Okay, starting at the top, the main function that we're going to run, and I'm just going to run it manually here from the module. I'm not going to create a button or anything, is get steady profile data. We're first dimensioning a few variables, like the worksheet, for instance, I'm calling steady flow. In fact, that reminds me, I need to actually change the name of the worksheet. So down here, the default is sheet one. Boom, now it's called steady flow. One of the first things I'm going to be doing is grabbing this file path to the .f01 file. So I think that's, yeah, so that's right here. What I'm doing is opening up this file path. It's using handler number 1 because that is in, let's see, row 2, column 3. Let's double check. Row 2, column 3. Yes, that is the target cell location for the file path. So that's the file path, and then we're opening up the file. All right, after that, we're just printing out the titles, river, reach, and river station in row 4, columns 3, 4, and 5. So that's going to be row 4, 3, 4, and 5. As you can see, I've already started building this manually just as a way to make sure that my target cells are where I want them to be. It makes it a little bit easier when I'm writing out the exact cell locations of where I want things to go. All right, below that, we're going to get the profile names and then print the profile names. So that's going to be this right here, TF1, TF2, and TF3. We'll go into the details of that a little bit later. And then after that, I'm going to get the river names, reach names, and river station data, and then print out the river names, reach names, and river station data. So where that's taking place on the worksheet is everything below row 4, basically. I'm printing out the river name, reach name, river station, and then also the flow profile data based on however many flow profiles there are. This code should be flexible enough to read in the number of profiles and then extend the data as far as there are profiles. So that's kind of a high level right there on what this function does. In fact, the very end of it closes the file and then ends the subroutine. So the only real magic to explain after this main subroutine that we talked about is this get data. Let's talk about the profile names first because that's a little bit more straightforward. We're first going to create a collection, which sort of works like an array in Visual Basic, except there's a little bit more flexibility to it, and the actual syntax is a little bit different. For instance, you can push an item onto a collection, but you can't push an item onto an array, at least not in VBA the way you can in JavaScript or Python. So you don't have to know the size of the collection, you can just add to it. And also when you're setting a collection, you actually use the word set. It's a specific keyword for collections. And what it's doing is it's going to call this get data function, and it's going to be passing in 3 parameters. And this is a function I wrote. So parameter 1 is the file itself, which is number 1. And then second, this is the key value that we're going to be seeing when we open up the text right here. This is the key that it's going to be searching for, profile names. So that's going to be read in by value as a string. And then one right here, this is something goofy I kind of made up as a way to understand how the data itself is parsed. One is going to represent comma delimited. I may change this in the future, so I'm just kind of building my library at the moment. But I'm going to say one is comma delimited. And then if you scroll down and compare to the other function call to get data, I'm going to be passing it the file. And then I'm going to be passing it this string right here, river reach ampersand rm equals, which is for this string right here. It's going to be searching for that. It's going to find it 3 times. But then for the, let's see, what am I calling it? I'm calling it delimiter ID down here. Here's the function get ID or get data. Delimiter ID, I'm passing it an 18. So that's just the ID that I came up with. For the first line is comma delimited, and then the second line is 8 characters at a time. And the reason I did this is because first we have comma delimited data for the first row, and then the next row is going to be 8 characters at a time, meaning this flow of 100 CFS can actually occupy all 8 of these characters right here. And then the second flow profile is using the next 8 characters right here. And then the third flow profile is using the next 8 characters. So if your first flow profile was 1.1, it would look like that. If it was 150, it would look like that. If it was 0.555, then you'd actually have to space it out. So you have a space, 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 and then 4, 5, 6, 7, 8. So that's how that works. There is 8 character space limiting parsing within these files, as well as 16, as well as probably some others I haven't been aware of yet. So I'm sort of building this as I go, but just keep in mind you got to be flexible when building your libraries and making sure the spaces are correct. So 5 spaces, 1, 2, 3, 4, 5. That should be good. I'm going to go ahead and save that before I make any more mistakes here, and then return to the code. As far as printing out the flow profiles, let's see, I'm starting in column 6 right here, row 4, and I'm just going to increment the column value as I print out each of the profile names. So remember, profile names here, PF1, PF2, PF3, those are saved in a collection. Another nice feature of the collection is you can use a for each loop. You don't have to know the size of the collection. So that's going to be printing out PF1, 2, and 3 in these cells right here. Once we have the collection built for the river data, what we're going to do is, again, loop through the values in that river data collection. Then we're going to print the value on row, row, column, column, which is going to start at 3, 5. So row 5 is just the next row down. That's right here, 3, 5. And we're going to print out that data for 3 plus however many flow profiles exist. So because we have 3 flow profiles, the length of the flow profile collection is 3, which means we're going to print out 6 different values here, and then we're going to advance to the next row and then reset the column counter to 3. And that is what's happening right here. So I'm checking if the column is 3. Oh, well, I'm starting at 3, so that's why this is 6. But if the column exceeds, what would that be? 9. So if the column happens to be 9, 3 plus 6, then it's going to reset the column to 3, and then the row is going to increment to the next row down, which would be row 6. All right, so that's how that works. Let's go ahead and see if that runs, and then we'll take a look at this get data function in some detail. All right, so let's move this out of the way. I'm going to delete this data right here, just so I know that that is actually being populated. Okay, so let's go up to run, and then run. Okay, boom. So here is the data. It printed out as we expected. So we have our 3 flow profiles, and then after that, we have the actual data that we saw when we were building this in the GUI. All right, let's take a quick look at that get data function now. Scroll down to get data. I'm reading in the file number, and then the key, that is the string that we're searching for within that file, and then the delimiter ID. Now, there's a number of other variables here that we're mentioning. So for instance, we've got a couple collections, a temporary collection, and then the actual return data collection. That's what's going to be returned at the very bottom of this function, just before the end of the function. Lines right here, this is initialized as a variant, but where we're using that is right here. So for instance, the entire steady flow file, that .f01 file, is parsed into individual lines. So this lines becomes a string array when we use the split, and then the delimiter is VBCRLF. That refers to the line break in Visual Basic. So file content right here is the contents of the text file, and now lines is a string array where each value of the array is a string for each line of the file. So we're going to now loop through each line of that file. And what we're searching for is the key, which was passed in earlier. So this should look familiar. This was covered in lesson 14. And then here is the value. I'm getting value from line. So what this function does, and I have it written right here, it's a very short, simple function. And what it does is, for instance, if this is the line right here, then it's going to return this is the value, everything after the equal sign. So if this is the line right here, this is the value. It's just a few lines to search for the equals symbol, find the position, and then return everything after that. Okay, so that's the get value from line function, which is right here. And then after that, I have a temporary collection, which I'm going to set to the result from get values from value. Here is value, which is going to be the result from up above. So PF1, comma, PF2, comma, PF3. And if the delimiter ID is 1, then it's going to know to just change that string to a collection, a temporary collection, which is just 3 items, PF1, PF2, and PF3. So where value is the string, the temporary collection in this case would just be those 3 values, but you're not going to see the comma. It's just going to be those 3 values. And then after that, I'm going to populate the return data collection just by using the add method. And then item would be my PF1, PF2, and PF3. Again, return data is what I'm returning from the function. So that pretty much explains how that works for the comma delimited. Remember, delimiter ID. Let's go ahead and take a look at this. Get values from value, which is the last function I have right here. Get values from value. We have the value right here, which would be the string PF1, comma, PF2, comma, PF3. And then the delimiter ID would be the 1 in this case for comma delimited or comma separated. That would be case 1, comma separated. And then it's just going to use this split values. And that's what the split values does. Values right here is set to a string array. And then I also have C for the collection. This is what I'm going to return from the function. So that array of string values is going to populate the collection in this little block of code. It's a short for loop that loops through all the values. And I'm also using a trim function. So there's no white space, there's no extra characters. And then that collection is returned. The only difference between the comma delimited, which I'm using delimiter ID 1 and 18 for the river reach and the actual flow rates, is further down here. So the delimiter ID is what I made up for the situation where the first line happens to be comma delimited, so I want that to take place. But then the next line is going to be delimited by 8 characters. So what I'm doing here is before the end of this main loop, I'm saying increase I by 1, so increment the line counter once again, get the values from that line, and then I'm going to send the values with a delimiter ID 8, which is my code for parsing a string every 8 characters. And then everything else is the same. So the return data and the return data, that's the collection. We're adding items that's returned from the temporary collection. So let me show you what that looks like. Case 8 right here does what I just said. It's going to count the number of values by rounding up based on the length of that passed in value. And then it's going to use this worksheet function mid, which is going to add to this values string array every 8 characters. And then again, further down below, we're going to add to the actual collection C that's returned from the function by trimming that data. So for instance, if we have space, 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 100, it's only going to return the 100. So anyway, that was a lot of talking, and let's just go ahead and see it in action once again. I'm going to clear out the results and then scroll up to the top here into the main subroutine and then run it. So boom, here is the data. This exercise was a lot of talking. Hopefully, you were able to view the code, write your own code. By all means, steal some of my ideas, none of which are fully solidified because I'm just learning about this and writing my own libraries at this moment. But eventually, things will become a lot easier once we have already built some of these basic building blocks and understand the structure of these input files. So we can write these string operations in order to extract the data for when we need it.